Hello everyone, this is Vasant, a ninepointer at IIT Bombay from the Department of Civil Engineering. Today we are going to solve one problem on statically indeterminate structures. So this is the problem. So you can see over here. 1 minute. Yes. So this is the problem. If you read this problem, it is a bimetallic bar or a composite bar. Composite bar का मतलब यह है कि tail should be same. In suppose see, this is made up of some material P1 value and this rod is made up of another material P2. Okay, so and it is welded to each other, it is connected to each other, and they said that it is composite bar. So it is restricted here, okay, like this. So whatever load you may apply, this end will move some distance delta. Okay, this end will move delta 1, delta 1. It means these will move straight. You may think that this is E1 and the load is some P1 and this is E2, the load is some P2, then this will move to some value, this will move to somewhere here, and this will move to somewhere here. But that won't happen in compound bar. Compound bar का definition ये है कि means they are made such that they elongate by same amount. Okay, so this is the condition for compound bar. Of square cross section with the dimensions 2b, this is also 2b, 2b into 2b. Is constructed two different metals having modulus of elasticity E1 and E2. See, entire this bar has modulus of elasticity E2, entire this bar has modulus of elasticity E1. So means this material entirely made up of homogeneous and isotropic with E1 with elastic modulus of elasticity E1. So this is also homogeneous and isotropic with modulus of elasticity E2. Okay. Okay, so the two parts of the bar have same cross-sectional dimensions, that is B into B. You can observe, sorry, not B into B. So this is 2B, right? This is 2B, this is B. They said that same cross-sectional area, cross-sectional dimension. The bar is compressed by forces P acting through rigid end plates. So these are rigid. These plates are rigid. What is the meaning of rigid? Means they doesn't undergo deformation. So there will be no deformations in the rigid bar, rigid plates, right? This is also rigid. So now the line of action of the loads has an eccentricity E, means it is applied at a distance E from the center. This is center line, and such that each part of the bar, see this is the important line, each part of the bar is stressed uniformly in compression. So this bar, if you cut one section over here, this bar, this cross section has entirely constant sigma, 1 sigma value, and this entire cross section of this second bar will also have some value of sigma which is constant over the cross section. Means uniform stress distribution on each bar. Their values are different, they are separately uniform. Okay, means that is some sigma 1, this is some sigma 2. So we already discussed one condition. So to have uniformly distributed stress over a cross section, the resultant load on that cross section should pass through the centroid of that cross section, right? We already discussed in previous lectures. So that is the point over here. So if you cut, see, if you cut over here, suppose if you cut over here and you take that off portion, so this is rigid plate and this is the center line. There are two bars, E bar, E1 comma A. Area of cross section is same for both. So this is E1, E2 comma A. Okay. So they said that this cross section entirely has one uniform stress distribution, right? So it should pass through centroid of this cross section. So suppose let us assume that it is compressive. So definitely compressive because PP is applied here and here, right? So that is definitely compressive. So P1, let us assume this is P1 and it should pass through center, right? So this is distance B by 2 because this whole distance is B. Right? Similarly, some P2 that should also be B by 2 from the center line, right? So this is the diagram. So now let us apply equilibrium equation sigma fx is equals to 0 to this part. Okay, so that will give you P is equals to P1 plus P2. That is one equation. Another equation is sigma m. Suppose you can take any point, right? So let us say center wala point O. So sigma m O should be is equals to 0. That will give you P into E, P into E, that is clockwise, and that is clockwise, right? And P1 wala anti-clockwise, so plus P1 into B by 2 anti-clockwise plus P2 into B by 2 that is clockwise is equals to 0. Means PE is equals to P1 minus P2 into B by 2. Okay. This is one equation. See, we need to find E, eccentricity E value, and P1 and P2, right? So there are three unknowns. So we now from equilibrium we only got two equations, right? So there is we need to have one more equation, but from equilibrium these are only the two equations. So that one equation will come from compatibility condition. What is the compatibility condition? So we already said that composite bar, right? It is a composite bar. So for composite bar, del should be same, right? So del 1 should be is equals to del 2. So what is del 1? Del 1 is equals to P1 divided by sigma 1 by E1. So that will be is equals to P1 divided by E1 A1 A. So del 2 will be is equals to sigma 2 by E2. Sigma 2 will be P2 divided by E2 A. So from these two we get that P1 by E1 is equals to P2 by E2. We get P2 is equals to P1 E2 by E1. So this is one more equation. Equation 3. So see, we need to find eccentricity E of the loads and determine the axial forces P1 and P2 in the two parts of the bar. Determine the ratio sigma 1 and sigma 2 of the stresses in the two parts of the bar. See, let us solve C part. C, what is sigma 1 by sigma 2, right? That is P1 by P2. Okay. So we need to calculate P1 and P2 first. So see, if you take P2, so if you put equation 3 in equation 1, equation 3 in equation 1, we get P1 into P1 plus P2 divided by E1 is equals to P. So that will give rise to P is equals to P1 is equals to PE1 divided by E1 plus E2. Similarly, P2 will be is equals to PE2 divided by E1 plus E2, right? So these are two. So then if you put over here, so what is P1 by P2? Then P1 by P2 will be E1 by E2. Sigma 1 by sigma 2 will be is equals to E1 by E2. Okay, this is part C. So we got P1 and P2. Then let us put these. Suppose so this is 1, this is 2, Roman 2. So let us put 1, comma 2 in equation 2. Okay, that is P into E is equals to P1 minus P2. P, what is P1? P1 is P into E1 divided by E1 plus E2. What is P2? P into E2 divided by E1 plus E2 into B by 2, right? So that will be PE is equals to P into E1 minus E2 divided by E1 plus E2, right, into P by 2. So P gets cancelled. So E will be is equals to P by 2 to E1 minus E2 divided by E1 plus E2, right? So this is eccentricity E of the loads. So see, we need to find out eccentricity E, that is part B. So this is part B. We already found out ratio of stresses, that is part C, and this is part A. This is P1 and P2, right? This is part A. Okay. So with this we completed this problem, and in next problem we are going to solve one more challenging statically indeterminate structure problem. Until then, take care. Bye bye from ninepointer.